Good evening, students. How are you guys? Yeah, yeah. You are all welcome to tonight's class. Okay. Tonight we'll be looking at equations reducible to quadratic equation, and it is 112 topic. Equations reducible to quadratic equation. Amen. Quadratic equation. Okay. So we know very well that quadratic equation is of the form ax squared plus bx plus c equals to 0. True or false? So we want to reduce, there are some equations that you have to reduce it into quadratic equation. That is when you can be able to solve. Is that clear? So we'll look at some examples. We'll look at some examples tonight. Are you following? So let's consider some examples tonight. Okay. One of the examples says solve the equation. Solve the equation. Solve the equation. Amen. 4 raised to the power of x plus x plus 1 minus 9 open bracket raised to the power of equals to 0. Yeah, I think so. Oh, equals to minus 2. Equals to minus 2, right? Okay, yeah. So we want to look at this equation, how we can reduce this equation to a quadratic equation. And this equation is also known as indicial equation. This equation is called indicial equation. Amen. So take note. Whenever you come across equations of this form, they are called indicial equation. You must first reduce it to a quadratic equation. That is, you must reduce this equation to this form: ax squared plus bx plus c equals to 0 before you'll be able to solve this problem. So how can we reduce this? So let's proceed. By the time we had minus 2 on both sides, we have 2 on both sides, or this crossing the sign of quantity becomes plus. So we have 4 raised to the power x plus 1 minus 9 open bracket 2 raised to the power of x open bracket plus 2 equals to 0. True or false? Any question? True or false? Do you have any question? True or false? It's true, right? Okay. So as you can see now, yeah, here look at here, we have 4 raised to the power of x plus 1. But here, the least here is 2. And 2 is raised to the power of what? This, x, right? So what we need to do, we have to reduce this, the least base here is 2, so we have to reduce it to 2 here. Is that clear? But if you can see what I am saying, don't be surprised. You know, in indices, if we have 4 raised to the power of x plus 1, you know that this is the same as 4 raised to the power x times 4. True or false? True or false, please? True or false? True or false? It's true, right? Oh, the plus. Yeah, the plus. You know, if we have a plus b equals to minus c, if minus c crosses the sign of equality to the left hand side, you are going to have plus a plus b plus c equals to 0. Is that clear? Like the same thing, assuming you have a plus b equals to c, here is plus, right? So if plus crosses the sign of this equality, becomes what? Minus. So a plus b minus c, this is equals to 0. Take note. So as it is, minus 2 crossing the sign of equality becomes plus. This is equals to 0. Do you understand? Are you following? Do you understand? Okay. So let us proceed further to look at it very well. Let's proceed further. So let me open your eyes. Let me open your eyes. I said we have to reduce this in this form, and I've said it before. We now say note that 4 raised to the power of x plus 1 is equals to 4 raised to the power x dot 4, right? True or false? So instead of this, we write it here. Then here we are going to have 4 open bracket 4 raised to the power of x, then minus 9 open bracket 2 raised to the power x plus 2 equals to 0. Amen? So we have to, the base here is 2 raised to the power x, so we need something like that. You know that if we have, okay, note also that, 4 raised to the power x is the same thing as 2 raised to the power of either 2 open bracket, all in bracket, raised to the power of x, and this is the same thing as 2 raised to the power of 2x. Is that clear? So take note. Are you following? Are you following? Yeah. Okay, so if you can see what I am saying, instead of this, we write this here. So here will now be 4 open bracket 2 raised to the power of 2x, then minus 9, okay, or this is the same thing as 2 raised to the power of x, all in bracket raised to the power 2. It's the same thing. Okay, 2 raised to the power x plus 2 equals to 0, right? So 4 open bracket 2 raised to the power of x, so that we will have the same thing, minus 9 open bracket 2 raised to the power of x plus 2 equals to 0, right? Any questions so far before we proceed? Do you have any question? Any question? No question. Any question? No question? No question, right? Okay, yeah. So let's proceed if there's no question. So you can now see that we have the same basis here. We have the same base here, the same base here. So what we need to do, for us to reduce this to this form, we can choose any alphabet, either P, K, thereabout. So let's go with K. We now say let K be equals to what is inside this two bracket. What is inside? 2 raised to the powers of x, right? Okay. So if you agree with me, because I want to reduce it into this form, ax squared plus bx plus c equals to what? 0. So as you can see now, anywhere you see 2 raised to the powers of x, you put k. So here will now be, this place will now be 4 open bracket k all square, right? Then minus 9 open bracket k, then plus 2 equals to 0. Are you seeing what I am saying? So far so good. This is the same thing as 4k square minus 9 open bracket k plus 2 equals to 0. Let's multiply out the bracket. 4 times k square, we are going to have 4k square. 9 times minus 9 times k minus 9k plus 2 equals to 0. Can you see now? We have reduced this initial equation to quadratic equation. So we can find the value of k. So from the value of k, we can now find the value of x. Is that clear? Any question before we proceed? Do you have any question? Yes or no? No question. Okay? Yeah. So how can we obtain this? Since we have reduced it into a quadratic equation, and we know quadratic equation, we have method of completing the square. We also have formula method and factorization method. We can use any of the 3 methods, since it is not specified here that use so method. So let us use formula methods to save time. Yeah. So if we are to use formula method, we now indicate using the formula method, right? To obtain k. Right? So it means our k is equal to minus b plus or minus square root of b squared minus 4ac all over what? 2a, right? So where is our a? Because look at it, we compare it with this, where a is isn't it? True or false? It's true, right? It is true, right? Okay. So far, so good. So let's substitute in the values to obtain our k. Our k will now be equal to b is minus open bracket minus 9 plus or minus then square root of minus 9 all in square minus 4 times 4, a is 4 times 2 all over 2 times 4 because a is 4, right? So far so good. Our k is equal to minus times minus. We are going to have plus, so 9 plus or minus. Then when we have minus 9 all in square, this means minus 9 times minus 9, minus times minus plus 9 times 9 is 81, right? Yeah. So here is 81, then minus 4 times 4, 16 times 2, 32, right? 32, then all over 2 times 4, 8, right? Okay, let's do 32. I want you people to write it in the comment section. 81 minus 32, please. The first 5 people. I'm going to score you mark. What is 81 minus 32? Please, I'm waiting. 81 minus 32. What is 81 minus 32? Write it in the comment section. (81 minus 32). Use your calculator now. 49, yeah. Amudu, Chidara. 49, I love that. You are good. Thank you very much. Yeah. So we are going to have 49. So here, our k is equals to 9 plus or minus, then square root of 49 all over 8, then this is equals to, what is square root of 49? 7, right? So 9 plus or minus 7 all over what? 8. You know, when we say plus or minus, when you see something of this form, this is the same equals to plus minus. So we first consider this and then this. So our k1 will now be equals to 9 plus 7 all over 8. Then this is equals to 9 plus 7 is 16, right? 16 all over 8. Then 16 divided 8 is 2, right? So our k1 is equals to 2. Then k2 will now be equals to 9 minus 7 all over 8. Then this is equals to 9 minus 7, 2, right? 2 all over 8. Then this is equals to 1 all over 4. True or false? True or false? True or false? True or false? It's true, right? Okay. It is true. It is true. Yeah. So far, so good. So let's come back to the question. Let's come back to the question. You know, the variable here is x. Talking about x, so we have to find the value of x and not k. So from the value of k1 and k2, we can obtain our x1, x2. So far, so good. So now So now you write at K1 equals to 2. Remember you said let K, true or false, be equals to 2 raised to the power of x, isn't it? So as K1 equals to 2, so anywhere you see K, you write 2. So here will now be 2 raised to the power x is equals to K, 2. Amen? So if you can see what I am saying, this is what? This and this will go to give us, it means x is equals to 1. True or false? Then at K2 equals to what? 1 all over 4. Amen? 1 all over 4. It means you said let K equals to this. So remember that your K is this. So 2 raised to the power of x is equals to 1 all over 4. But in indices, when we have 1 all over 4, this is the same as 4 raised to the power of minus 1. True or false? True or false? It's true, right? It is true. Yeah, it is true. So, if you can see what I am saying, amen? So, let's transform this in this form. 2 raised to the power of x is the same thing as 4 raised to the power of minus 1. Then, we apply indices. Since the basis here is what? The base here is 2, so we have to make sure the base here 2 to be 2. So you know that 4 is the same thing as 2 raised to the power 2. True or false? So our 2 raised to the power of x is equals to 2 raised to the power of 2 minus 1. Amen? So by the time you multiply, our 2 raised to the power of x is equals to 2 raised to the power, so we are applying this is here, minus 2, right? So this and this will go. Therefore, our x is equals to minus 2. Any question, please? Do you have any question? Do you have any question? So, the solution of x is minus 2 and plus 1. Any question, please? If there is no question, let's proceed further to solve more examples. If there is no question, let us proceed further to solve more examples. Do you have any question? Yes or no? Okay? If there is no question, let us proceed further to solve some problems. Let's proceed further to solve some problems. No question? Let us fix idea with some examples. Okay. Let's consider more examples. If log 2 log x equals to log 3x log 3x minus 2. Find x. Amen. Find x. We have to reduce. Yeah, let's fix idea with this example so that so let's fix idea with this example, right? Okay. Yeah. So what do we do? Let's write solution. 2 log x is equals to log 3x minus 2. So we have to reduce this to a quadratic equation. Note that in laws of logarithmics, when we have n log a, this is the same thing as log a raised to the power of n. True or false? True or false? It's true, right? True or false? True, right? Okay. So true or false? Am I right? Okay, so let's proceed. So if you agree with me, it means that is our 2 log x is equals to log x raised to power 2. So here will now be log x raised to power 2 is equals to log open bracket 3x minus 2. Then this and this will go. So this implies that here we have x squared is equals to 3x minus 2. Then x squared minus 3x, crossing the sign of equality, here will be plus 2 equals to 0. You can now see that this is a quadratic equation, true or false? This is a quadratic equation. So you have to reduce it. We have reduced it to a quadratic equation. So I want somebody to solve this equation and tell us the answer. I'm going to give you marks. Somebody should solve that problem. I want somebody to solve that problem. And write the answer. Somebody should solve that problem. Somebody should solve that problem. And tell us the answer. Nobody? Nobody to solve the problem. Who has solved this problem? Okay, Dauda Yusuf. Okay, yeah, let's try together. X is equals to minus b plus or minus b squared minus 4ac all over 2a. Then our x is equals to minus open bracket minus 3 plus or minus square root of minus 3 all in square minus 4 times 1 then times 2 all over 2 times 1, right? Okay? Then our x minus times minus equals to plus, plus or minus, then square root of 9 minus 8, then all over what? 2, right? X is equals to 3 plus or minus root 1, right? Because 9 minus 8 is root 1 all over 2, then x is equals to square root of 1 is 1, 3 plus or minus 1 all over 2, and x1 will now be equals to 3 plus 1 all over 2, which is equals to 4 all over 2, which is equals to 2. Then x2 is equals to 3 minus 1 all over 2, which is equals to 2 all over 2, which is equals to 1. So therefore, our x1 is equals to 2, or x2 is equals to 1. Yeah, I think that you got it. I think you got it. I'm owing you 2 marks, so remind me in class. I am owing you 2 marks, so try and remind me in class. Is that clear? Try and remind me in class. Try and remind me in class. Then let's consider another example. Let us consider another example. Let's consider another example. Solve solve for x, solve for x if we have 2 raised to the powers of 2x plus 8, right? I'm not mistaken. Yeah, minus 32 open bracket raised to the powers of x, then plus 1 equals to 0. It's a very good question that I want to look at. Very good question. It's a very good question. Okay, yeah. Let us look at it together. Let's look at it together. So let's write solution. Our 2 raised to the powers of 2x plus 8 minus 32 all in bracket 2 raised to the powers of x plus 1 equals to 0. Note Now when we go back to indices, when we have 2 raised to the powers of 2x plus 8, this is the same thing as 2 raised to the powers of 2x times 2 raised to the power 8. And this is the same thing as that 2 raised to the power x, open bracket, raised to the power 2 times 2 raised to the power 8. This and this, they are the same thing. Please take note. Are you following? Do you understand? Take note. Okay? So, what do? We have to, instead of this, we write this. So here will now be 2 raised to the powers of x is because of this, so that we reduce the base to the least, raised to the power 2 times 2 raised to the power 8, then minus 32, open bracket, 2 raised to the power of x plus 1 equals to 0. We are doing this because we want to reduce it to a quadratic equation. So how can we reduce it? Since this and this, they are common, we now say let any alphabet p be equals to 2 raised to the powers of x. So if you agree with me, here will now be p squared, because here you substitute in for p, open bracket, 2 raised to the powers of 8 minus 32, open bracket, p, close bracket, plus 1 equals to what? 0, right? Okay? So at this point, what do? We have to multiply out. If we have 2 raised to the power 8, this means 2 times 2 times 2 times 2 into 8 places. Is that clear? So, give us the answer, please. Somebody should type the answer. I'm waiting. Somebody should type the answer. Somebody should type the answer. Somebody should type the answer. 2 times 2 times 2 times 2 times to 8 places. No, louder. Not 16. 2 times 2 into 8 places. Into 8 places. 1, 2, 3, 4, 5, 6, 7, 8. You are going to have multiply it. What is the answer? Nobody. You have 256. 256. So here will now be p squared, open bracket, 256 minus 32, open bracket, p plus 1 equals to 0. Multiply 256 p squared minus 32p plus 1 equals to 0. Alright? Equals to 0. Do you understand? Equals to 0. So we either use factorization or method or formula method. But looking at this, the factor 16p minus 1 all is square equals to 0. This will give you this quadratic equation again. You either use what is it called? Formula method or factorization method. So, but the fastest output is this. 16p minus 1 all in square. It will still give you back this. That here. So far so good. Here we're going to have 16p minus 1 all in square. By the time you square both sides, we have 16p minus 1 equals to 0. Then 16p is equals to plus 1. Then divide through by 16. Our p will now becomes 1 all over what? 16. Okay? But here we say let p equals to, so let us recall that p is equals to what? 2 raised to the power x. Then our p is 1 all over what? 16, right? So here we now be 1 all over 16 equals to 2 raised to the power x. We can rewrite this equation in this form. 2 raised to the power x, and this is the same thing as 16 raised to the power of 1 all over 16 raised to the power of minus 1. Then it's the same thing as this, because go back to your indices. So here the base here is 2, so we can reduce this to 2. So let us 16, 2, 8, 2, 4, 2, 1, 2, sorry, 2, 1, right? So 2 into what? 4, right? So here will now be 2 raised to the power x equals to 2 raised to the power of 4, open bracket, raised to the power minus 1. Then our 2x raised equals to, this times this, 2 raised to the power of minus 4. This and this will cancel. Our x is equals to minus 4. Any question, please? Do you have any question? Any other question? So I want to give you guys assignments. Make sure you know how to solve this problem. It's very important. If 25 x raised to the power 2 plus 25 x raised to the power 2 minus 1 all over 5x squared minus x equals to 26 all over 25. 26 all over 25. Solve for x. Please, you have to solve it now. let me just give you an hint from here. Look at the board very well. This plus okay. Yeah. You can see what I am saying. This is the same thing as 25 raised to the power of x squared plus 25 x squared. Note that when we have something of this form, x squared minus 1, this is division. 25 x divide 25. True or false? So that the basis, the power will subtract each other. So let's do it this way. Divide 25 all over what? 5x squared minus x equals to 26 all over 25. So here, if you can see what I am saying, we can reduce this way, since 5 is the denominator. So this is 5 raised to the power of 2, all in bracket raised to the power of x squared, then plus 5 raised to the power of 2, all in bracket raised to the power of x squared divide 5 raised to the power of 2. Yeah, all over 5 raised to the power of 2x x squared minus x equals to 26 all over 25. Amen? Okay? So, as it is, we can transform this way. By the time we remove this sign, turn it to multiplication, here will now be 5 raised to the power of 2, open bracket, x squared plus 5 squared raised to the power of x squared times 5 raised to the power of minus 2 all over 5 raised to the power of x squared minus x, then equals to 26 all over. You are going to see this question in the exam. Take it down. This question, you will see it in the exam. Very important. This question is very important. You see it in the exam. Don't play with it. You will see this question in the exam. It's very important. Please. So far, so good. So, if you can see what I'm saying, what is common here? Here is yeah, true or false? Look at this thing. Something is common here. What is common here? 5. Okay, we can this is the same as 5 raised to the power of 2x squared plus 5 raised to the power of 2x squared dot 5 raised to the power minus all over. I'm almost done with it, or I'm just solving it for you. So you go and finish the rest, the remaining parts. So something is common here. So we factor it out. X squared, amen. Open bracket 1 plus 5 raised to the power of, then equals to 26 all over 25. All over 5x squared minus x, right? True or false? So, gentlemen and ladies, I want you guys to finish this problem, how it is solved, because you will see it. Is that clear? So, your time is up. Let me welcome and the 2 students to learn calculus. Although if you don't mind, you can be part of it because you are going to do it second semester. Our second semester is not far. So let's welcome the two students. Yeah. Okay. Yeah. We'll be looking at successive differentiation. Successive differentiation. Okay? Yeah. Okay. Yeah. If or we can call it higher derivative or higher derivative, yeah, if now you have been given y equals to 3x raised to the power 4, then you say find y prime or y prime prime y prime prime y iv and yv. You know that this is the same as dy all over dx. Take note. This is the same as d square y all over dx square. Then this is the same as d cube y all over the x cube. This is the same as d raised to the power 4 all over yes, and this is the same thing as d raised to the power 5y all over the x raised to the power 5. Yeah. So just take note of this. So it means we are going to differentiate that function again and again and again and again up to 5 times. So now let us write solution. Our y is equals to 3x raised to the power of 4, right? So if we are to differentiate the first derivative, it means our dy all over the x is going to give us, use this 4 to multiply what is here, 3, right? So 4 times 3, 12x raised to power 3. Then let's find this d square. Okay, let me just do it this way so that y prime is the same thing as dy all over the x, which is equals to 12x raised to power 3. Do you understand? Are you following? Do you understand? Yes, right? Okay. Then here, so let's consider this y prime prime. That is y prime prime is also the same thing as d square y all over the x square, which is the same thing. You differentiate y prime to obtain y prime prime. You are not coming back to differentiate y. Please take note. If you want to obtain y prime prime or d square y all over the x square, you have to differentiate y prime to obtain your y prime prime. Do you understand? So what we need to do, use this to multiply this, So you are going to have 36, right? 36x raised to the power of 2. Then let us obtain y prime prime. It means you are going to differentiate y prime to obtain y prime prime. So here will be y prime 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 is the same thing as d cubed y all over the x cubed. This is, use this to multiply this 12, which is 72, right? 72x, isn't it? Then we are going to differentiate y prime 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 to obtain y iv. That is y iv is equals to d raised to the power 4 y all over the x raised to the power 4. And this is, it means we are going to differentiate y prime prime to obtain y iv. So if you differentiate this 72x, you are going to have what? 72, right? Then we are to differentiate yv. So for us to differentiate yv, obtain yv, we have to differentiate yiv to obtain. So our yv is equals to d raised to the power of 5y all over the x raised to the power of 5. Then this is a constant. So whenever you differentiate a constant, you obtain what? 0. So can you see now? Amen? Do you understand? Yeah. So, any question before we proceed? Do you have any question? No question? So, can we proceed? Amen? Okay. So, now, let's further to solve some questions involving before we solve this problem, I want us to know that if you are to differentiate sec theta, please, your dy all over the the theta will always be sec theta times tan theta. So whenever you differentiate sec theta, it will always give you sec theta times tan theta. Please take note. Are you following? Take note. Is that clear? So what if we have y equals to 2 sec 4 theta? It means we are going to have our y all over the theta. Use this to multiply. We are going to have 8 sec 4 theta times tan 4 theta. Are you following? Do you understand? Do you understand? Yeah. So please, you should take note. Take note. Take notes. Take notes. So let's consider this. Let's consider this. Okay, evaluate evaluate d square y theta, d square y all over theta square when theta equals to 0. Okay? When theta equals to 0, given y equals 4 sec 2 theta. Amen? So, let's proceed to consider this. As simple as ABC. Okay, so now here let's write solution. Y is equals to 4 sec 2 theta. Don't be surprised if they want to confuse you. Instead of this, they can transform this to y prime prime, evaluate y prime prime when it's the same thing. Please take note, when theta equals to 0, given y equals to 4 sec 2 theta. Please take note. Is that clear? It's the same thing. Take note, right? Okay, so let's consider this. It means we are going to find the value. We'll differentiate this function up to how many times? Twice, because of what is here. So let us obtain the first derivative. So the first derivative will now be dy all over the theta is equals to differentiate this. Use this to multiply this, that is 4 times 2. Then when you differentiate sec 2 theta, you are going to have sec 2 theta times tan 2 theta. Going by this. True or false? It's true, right? Do you understand? Do you understand, right? Okay. So if you agree with me, it means this is going to give us the y all over the theta is equals to 4 times 2, 8 sec 2 theta times tan 2 theta. True or false? So for us to obtain d square y all over the theta square, look at this. Look at this. We can use product rule or we can differentiate this function direct. True or false? We differentiate this one, hold this one, use to multiply, then hold this and differentiate this one. Or you use product rule, whichever way you want to do it. Are you following? Whichever way you want to do it. So, are we to use product rule? Or which one do you want us to use? Which one do you want us to use? Okay, let's differentiate it direct. Oh, you want us to use product rule? Okay, let's use product rule and see. If not, I wanted to you may see this type of question in your exam, so please take notes. Yeah, take notes. So let us use product to write y is equals to uv. Then let u be equals to 8 sec 2 theta and v be equals to what? Tan 2 theta, right? So let's differentiate this. Our du all over the theta, we are going to have 16 sec 2 theta times tan 2 theta, right? Okay. Then let us differentiate the v all over the theta. We are going to have 2 sec square theta, isn't it? True of course. Okay, so let us write down the formula for our dy over the theta will now be equals to u dv all over the theta plus v du all over the theta. True or false? So far so good. It means we are talking about this square y, yes. Okay, so our d square y all over the theta square is equal, what is our ordinary u? Ordinary u is 8 sec 2 theta, right? Then the v all over the x times 2 sec square theta. Then what we have here plus v, ordinary v is tan 2 theta, then times, okay, let me just write it here, down here. Let me write it down here so that you can see it clearly. D square y all over the theta square is equals to 8 sec 2 theta, right? Then here is 2 sec square theta, then plus ordinary v is tan theta, tan 2 theta, then times du all over the theta is 16 sec 2 theta times tan 2 theta. Yeah. Am I right? So this is what we are going to get after using product rule. After using product rule, this is what you are going to get. Is that clear? Okay. So far so good. Then now the question says when theta equals to 0. When theta equals to 0, so when theta is equals to 0, so it implies that anywhere you see theta, you substitute in 0. So let's come here. When theta equals to 0, so this implies that we are going to substitute in theta. So it means our d square y all over the theta square now be equals to open bracket 8 sec 2 times 0 close bracket times 2 sec square theta is 0, right? Then plus tan 2 open bracket 0, then times 16 sec 2 open bracket 0 times tan 2 open bracket 0 close the bracket, right? Am I right? This, true or false? So here will now be y all over theta equals to open bracket 8 sec 0, right? Times 2 sec square 0 plus tan 0 plus 2 times 0 is 0. Next times 16 sec 2 times 0 is 0 times tan 2 times 0 is 0, right? Am I right? So after pressing calculator, the final answer is going to be 16. Go and press your calculator. Therefore, d square y, the theta square is equals to 16. Please take note of this question, please, very important. So let's proceed to solve more examples. Let us proceed. Let's consider another example. Let's consider that if y equals to cos x minus sin x, example, if y equals to cos x minus sin x, evaluate x in the range equals to x less than or equals to pi all over 2. This is 90 degrees, right? In between 0 to x is in between 0 and 90 degrees. Then when d square y all over the x square equals to 0. Yeah. So let's look at it together. Amen. Let's look at it together. Okay. Yeah. So when you come across this type of question, what to do is for you to differentiate again and again. You have to differentiate again and again. Differentiate again and again. So let's write solution. Our y is equals to cos x minus sin x, right? Okay. So let us differentiate this. Once our dy all over dx is going to give us, if you differentiate cos x, you are supposed to have minus sin x. If you differentiate sin x, you are supposed to have cos x, right? Then we have to differentiate it again the second time. So we differentiate d square y all over the x square. This is because if you differentiate sin x, you have cos x. If you differentiate sin x, you are going to have minus sin x. Now, if you differentiate cos x, you are going to have minus sin x, right? Then we have minus here. Easy to multiply. You are going to have plus sin x, right? But note that the second derivative is equals to 0. So this is equals to minus cos x plus sin x, right? Yeah. Well, that is, if you can see what I am saying, that is, if you make either sin x or cos x the subject of the formula, it is either our sin x is equals to cos x. True or false? Yeah, isn't it? Look at it, and here is 0. True or false? It's true. So this is isn't it? This is either sin x all over cos x, which is equals to what? 1, right? So it means this is tan. Our tan x is equals to 1. So x will now be equals to tan inverse of 1, right? Tan inverse of 1. You are going to have either 45 degree or pi all over 4 radian. True or false? Press your calculator in the range of 0 less than x less than 2 pi all over what? Pi all over 2. Yeah. So this is how you are going to consider this type of question. Yeah. Do you have any question before we proceed, gentlemen and ladies? You have any question? No question. Please don't forget to share, like, no question, so we can proceed, right? Abdulsal, Abdulbasit. I know you are just coming, and you are coming to tell us that you don't understand. Okay, let's proceed. Let's move further to consider some examples. Okay. So with this we can solve problems. Okay, let's look at given y equals to given y equals to 2x exponential minus 3x minus 3x. It says show that d square y all over the x square plus 6dy all over the x, 6dy all over the x plus 9y equals to 0. It's simple as ABC. We'll look at it together. Is that clear? It is not difficult. We'll look at it together. Okay. Yeah. So let's write solution. Y is equals to 2x exponential minus 3x. Yeah, I know very well that I'm not taught you how to differentiate exponential functions, but let me just do it here. One or two examples, then we proceed. When we call this exponential functions. These are exponential functions. Amen. Exponential function. So if you are to differentiate exponential function, our dy all over the x is equals to, just assume that is x you are differentiating. So if you differentiate x, you are supposed to have 1, true or false. Then use this one to multiply this thing. That is the answer. So 1 times exponential x is the same thing as exponential x. So you can now see that dy all over the x is going to give you exponential x. Do you understand? Then, assuming you have y equals to exponential 2x, then they ask you to find dy all over the x. Just do the same thing. Just assume that what is there? 2x, right? Just assume that you are differentiating for 2x. So if you differentiate 2x, you are supposed to have 2. Use this 2 to multiply whatever that is there. That's the answer. So our dy all over the x is equal to 2 exponential 2x. Any question? Because we are going to somewhere. Yeah. Amen. Then, assuming you have let me clean this. Assuming you have exponential minus x, just assume that you are differentiating from minus 1 x. So if you differentiate from minus x, you are supposed to have minus 1. So this implies that your dy all over the x, use this minus 1 to multiply whatever that is here, minus 1 times exponential minus x. You can now see that dy all over the x is equal to minus exponential minus x. Because minus 1 times exponential is the same thing as true or false. So this one that we have let's assume that we have it in this form, minus 3x. So if you just assume that you are differentiating for what? 3 minus 3x. If you differentiate for minus 3x, what are you supposed to have? Supposed to have minus 3. So use this minus 3 to multiply whatever that is here. Then your dy all over dx, you are going to have minus 3 exponential minus 3x. Do you understand? Are you following? Then, if they said differentiate this again, it's the same approach. It means d squared y all over dx squared will now be equals to, assume that you are differentiating for 3x. So when you differentiate minus 3x, you have minus 3. Amen? Is that clear? Then use this minus 3 to multiply what is here, minus 3. So minus 3 times minus 3, you are going to have 9 exponential minus 3x. Any question? This is how to differentiate exponential functions. So let's proceed to consider this problem. Is that clear? Okay. So far, so good. So now, this is a differential equation. We have d squared y all over dx squared plus 6dy all over dx plus 9y equals to what? 0, right? So, in this differential equation, we have second derivative, we have first derivative, and we have y, two of us. It implies that we should differentiate this function with respect to x up to how many times? 2 times. Then substitute it into this differential equation. Since the right hand side is equals to 0, after substitution, both this left hand side too will be 0. This is how this equation will look like. 0 equals to 0. This is what they want. Is that clear? So how can we do that? We have to differentiate this function with respect to x twice. So let's differentiate. When you look at this function, look at it. We have 2x exponential minus 3x, two of us. So as you can see, we have two functions multiplying each other. This is one, then this is another one. So we are going to use what? Product rule. But using product rule will take our time. We just differentiate it direct. Is that clear? We differentiate it direct. So what we need to do here is our dy all over dx, we are going to have, you hold this one, differentiate this. So if you differentiate exponential minus 3x, you are going to have minus 3. Use it to multiply 2x, you have minus 6x exponential minus 3x. Then, since product rule is plus, then hold this, differentiate this. You are going to have, if you differentiate 2x, you are going to have 2. Use it to multiply exponential 2 exponential minus 3x. This is the first derivative. Then the second one will now be d squared y all over the x squared is equals to, here is, we are still going to use product rule, but here we differentiate it straight. But we are still going to, we hold this, then differentiate this. If we differentiate minus 3x, we are going to have minus 3. Use it to multiply minus 6x, we will have what? Plus 18x exponential minus 3x, then plus, note that there is minus sign, then differentiate minus 6x, you are going to have, hold this for constant, differentiate minus 6x, we are going to have minus 6 exponential, used to multiply the exponential 3x, then plus differentiate differentiate this, you are going to have, because 2 is a constant, so differentiate minus 3x. Mind you, if you differentiate minus 3x, you are going to have minus 3. You need to multiply 2 exponential this, you have minus 6 exponential minus 3x. Am I right? Yeah. Okay. So far, so good. So, this implies that, let's write it, our d square y all over the x square now be equals to 18x exponential minus 3x. That is plus times minus, minus 6 exponential minus 3x, plus times minus, minus 6 exponential minus 3x. It means we can add this to give us our d square y all over the x square is equals to 18x exponential minus 3x. Then here will now be minus 12 exponential minus 3x, right? So this implies that anywhere we see d1 over dx, we write this in this differential equation. And anywhere we see d square y over dx, we write this in this differential equation. Then our y, we now replace it with this 2x exponential this. So let's do it together. Let us do it together. So far so good. Let me clean it up so that we start from the up. Amen. Okay. Okay. So what is this? Here is 18x exponential minus 3x, then minus 12 exponential minus 3x, amen. Then what we have here plus 6 divided over dx is this. So open bracket minus 6x exponential minus 3x, then plus 2 exponential minus 3x, close bracket. Then what we have plus 9y. What is y? Y is open bracket 2x exponential minus 3x, close bracket, which is equals to what? 0. Amen. Okay. Let us multiply out the bracket. Here is 18x exponential minus 3x minus 12 exponential minus 3x. This times this minus 36x exponential minus 3x. This times this plus 12 exponential minus 3x. This times this plus 18x exponential minus 3x equals to what? 0. Amen? Amen? Amen. Okay? Yeah. So as you can see, we don't need a prophet. You don't need a prophet to tell you. You can collect like this and this. Look at it. We can have this. Two of us. Then this and this will go, isn't it? Yeah. Then if we have 18x exponential minus 3x plus 18x exponential minus 3x, we are going to have 36x exponential minus 3x. Then what we have here minus 36x exponential minus 3x, then equals to what? 0. You can now see this and this cancel. 0 equals to 0. Amen? So this is how you are going to approach this type of question. This is how you are going to approach this type of question. Is it difficult? No. It is not. So let us consider another problem, example. Let's consider another example. Show that the differential equation, this to a y all over, another example, show that the differential equation d square y all over the x square minus 4 dy all over the x, amen, then plus 4y equals to 0 is satisfied when y equals to x exponential 2x. Whenever you come across functions like this, use product rule or you differentiate it direct. Is that clear? Okay. Okay, so we are going to approach this one same way we did the first one. Y equals to x exponential 2x. Then the differential equation is d square y all over dx square minus 4 dy all over dx square plus 4y. Okay, let me just transform this differential equation in this form instead of d, so that in case you see it, y prime minus 4y prime plus 4y is equals to 0. It's the same thing as this differential equation. Please take note. So what we need to do here is y prime minus 4y prime plus 4y equals to 0. So what we need to do, we have to differentiate this function twice using product rule or direct approach. So y prime is going to give us, hold this one, differentiate this, you have 2x exponential 2x, then plus hold this, differentiate x 1 times exponential 2x is exponential 2x. Then y prime is equals to, we are going to use product rule. Then we hold 2x, differentiate exponential 2x is 2. Use it to multiply 4x exponential 2x. Then hold this, differentiate 2x plus, with differentiate 2x, you are going to have what? 2 times exponential 2 exponential 2x. Then plus, if you differentiate this, you are going to have 2 exponential 2x. Then, yes, we can have this, and y prime is equals to 4x exponential 2x plus this one plus this, we are going to have 4 exponential 2x. Then we have to substitute this substitute this here and substitute this here, whether the left answer equals to 0. Okay? So instead of y prime prime, we write 4x exponential 2x plus 4 exponential 2x. Then what we have here, minus 4 y prime is this, right? Sorry, y prime is this. Then open bracket 2x exponential 2x plus exponential 2x close bracket. Then what we have here, plus 4 times y is x exponential what? So 4x exponential 2x equals to 0. Whether we are going to have this thing. So far so good. Here is 4x exponential 2x plus 4 exponential 2x. Open this bracket, minus 8x exponential 2x minus 4 exponential 2x, then plus 4x exponential 2x, amen, equals to 0, right? So you don't need a prophet to tell you. By the time this and this cancel, this and this will cancel. If you add this to this, you are going to have 8. This is what you are going to have. 8x exponential 2x minus 8x exponential 2x equals to 0. So this and this will go 0 equals to 0. This is how you are going to consider this type of question. Any question? So I'm going to drop assignment here. I'm going to give you assignment here. I'm going to give you an assignment you should look at. I'm going to give you assignment. You submit it in class. I'm going to give you assignment. Okay, do this. Take note of this assignment, it's very important. You are submitting it tomorrow. sin x okay. If y equals to s plus sin x, if y equals to x squared sin x, prove that x squared y prime prime minus 4x y prime then plus x squared plus 6 times y equals to 0. You are submitting it tomorrow. Make sure you find look for a way to solve this problem. Tomorrow morning, I'm coming to pick it up. Is that clear? And let me add another one. Okay. Should I add another one? Or I should just leave it like this? Let me add one. Let me add one. Let me add another one. Let me add another one. If this is 1, 2. If y equals to x sin x, prove that x squared y prime prime minus 2x y prime plus open bracket 2 plus x squared, right? 2 plus x squared times y equals to 0. 2. We're going to collect it tomorrow morning. Is that clear? Be serious about it. Please, I want you to be very serious about it. Okay, gentlemen and ladies, I'm going to call it a day for now. I wish you a wonderful night rest. Please don't forget to share and like. Thank you. See you guys, same time, same venue, next week, right? Love you guys. Bye. You are going to submit them tomorrow. I'm coming to pick it up. Thank you.